Okay, Anjana, you need to help me if there is any queries or questions in the chat because I'm not able to, since I'm on presentation mode, I won't be able to see the chat.
Hi everyone, a very good morning. We'll be starting in a while. So Sayan, if you can change your name because it's reflecting as Aishwarya. So,
I don't know how to do that. Uh,
uh, uh, okay, I can also change, I
yeah,
think. Let me see if I can change your name.
because I joined with Aishwari, with Shan name. Okay, got it. Now it's changing.
So we'll start at 11:05. We're waiting for more people to join. So very good morning to all of you. We have Sayan here from Telstra. So a little bit about Sayan. Sayan is a senior specialist, data, AI, product and technology at Telstra, a chapter lead. And he has, I think, 8+ patents in terms of technology, and also his passion is, I think, AI and machine learning and developing new apps. So I'll pass it on to Sayan to give a brief introduction, and then perhaps he can start with the today's topic in this series. So we have already had Sayan. I think you were also aware. We've had already 3 sessions, and they are all progressive. And we are today in random forest, which is a decision making, decision tree kind of thing, and it's all progression. So people who have joined earlier would know it. Otherwise, you can also go to FutureSkills Prime YouTube channel and refer to the older videos. We have them uploaded there. So Sayan, over to you.
Okay, first of all, thanks, Anjana, for having me on board here. So I would say that I'm happy to join the esteemed list of speakers and happy to be a part of the Telstra initiative, partnering with NASCOM on this initiative. So a brief about myself. So I have around 15 years of experience and I am a chapter lead heading the data science chapter in India of Telstra, and we have people like I have people reporting to me from Australia and India as well, and we work on different aspects on cybersecurity. As you know, it's telecom, so it's not just a churn modeling, but also we work on the fraud detection models. We work on cybersecurity. We work on networks like the mobile networks. We work on different aspects. Now we are exploring some of the Gen AI stuff with LLMs and all. So and as Anjana introduced, like I have some penchant towards innovation and I have got some patents under my name, but I'm really interested. I'm still learning a lot about this and interested in innovation and sharing knowledge. And here we are. So just before like Anjana, just for you, like I need you to be my eyes and ears because I think Zoom is having some problems for me, so let me know if you just uh, stop me in case there are some questions or anything on the chat because I won't be able to see the chat. So and just let me know if you are able to see my screen.
Yes, we are able to see your screen. If you can, I mean, right now because the font size is reasonable, if you put it on slideshow, perhaps it'll be more clear.
Is it better? uh, is it better?
We can't see the slideshow because I think you've shared the window which is having the slides. I think it might have opened in the new window.
Is it better now?
Do you want to reshare your screen
Yeah,
and
sure.
share the
Let me do
slideshow?
that. Let
Yeah.
me do it. Let me know if this is better.
Yeah, this is better and visible. Thank you.
Okay. So thanks everyone. So as Anjana said, we had a last session back in the back end of 2023 where we talked about decision trees. And the agenda for today is to I understand like many of you might have forgotten what's decision trees, but many of you also know decision trees and also probably have a fair bit of knowledge of what random forest is. So the idea for me was to kind of brush up on the key concepts of decision trees, because without decision trees there is you can't go to random forest, and then probably go into the pros and cons of decision trees, why we use it, and then introduce a concept which is we call as ensemble method, and through that the techniques of bootstrapping and going through the bagging techniques, of which one of them is the random forest. And then we have a small coding exercise. When I say exercise, it is something which as part of the deep tech club which I founded at Telstra, we did an exercise, and which is something related with cricket, which on random forest, which you all will enjoy. So with that, let me go to kind of the terminologies part. But before that, can I have something on chat? Like if you just put yes in the chat if you have already attended the last session with Vineet. It was in I think November 2023. So just wanted to know how many people have attended the last sessions, and this was part of his slide as well, like terminologies for decision trees. So just put yes if you have attended the last session, and if you don't, that's totally okay. That's why I've taken 2 or 3 minutes to take you more into this part. So regarding decision trees, we are talking about a node, like it's as written, it's an element that has attribute or variables, and a tree is a collection of node, and the topmost node of the tree is called a root node. So after the root node, it has some children, and then the last part of the children is what we call as leaf node, which doesn't have any children. That is the buck stops there. And why do we need to move from the top node to the bottom node is because, as per information gain, which is another concept which was introduced by Vineet in the last session, is that uh, we would want to have a better partition of the data, and that's what decision tree does. It is like it looks at each aspect, each node, and says whether it can be further divided or does it make sense to further divide it further and go down the node. So that's what we call the criteria, which path to follow. Now for a top tree, it can either go left or right, and then and or it can even stop there. That is based on some decision criteria. Now, this is what we talked about. Like there is some criteria to branch from the topmost tree to the other trees. And this is the leaf node, like post that there is no more further diversification. That means it has either reached the minimum sample size, or it can minimum size, or at least some of the information gain is not there. So I think when he talked to you about an example where the objective was to predict if the tennis game will be played. And sorry, bear with me if you have already attended a Vinny's session. I'm just uh, creating the context here. So for anyone to predict if the tennis game is if the game of tennis will be played, so the outlook, we can look at the outlook, and based on that we can see that whether it can be humid, overcast, or rain. Based on each of the variables or attributes, we even go deep down and see if the humid is very high, then the game won't be played. But if the humid is low, then it is yes. So at each of the node, there are some decisions to be made. At the end node or leaf node, where no decisions to be made, is the ones where we have a label, like whether it's a yes or no in this case. Till now with me? Okay, great. So this is where my question comes, like So decision trees, what's good with decision trees, probably when it covered it, but let me cover it and start from here, is decision trees are non-linear classifier, right? For example, from each of this, like we have non-linearity also tackled through this, through the trees. So it's a good non-linear classifier. It's easy to interpret. We are able to understand it better. It can handle both numerical and categorical data. So I hope people know what categorical data is. Like it has ordinal and other data which is there. And numerical data are the numbers. And the key part why decision trees are very relevant and very used in the data science world is because they are super fast. So creating a tree is probably a very fast affair, and that's why decision trees are useful. And we have seen that it has worked well on very large data sets. So it's scalable, it's kind of non-linear, so many advantages. So just wanted to know, like, do you have any idea what could be the problems with decision trees? You can write on the chat. So one of the problems, and this is where we need to move beyond decision trees, is regarding overfitting. Now there are other disadvantages as well, but in the context of time and since we are talking about random forest, I will talk about overfitting. Now, what does overfitting mean here? Is I could have given you a context probably later on. Is in in the decision trees we have a lot of observations, right? And say some of the training observations are kind of, if some value changes slightly, then the decision can also change. For example, if you look at the decision trees, just here whether it's the humidity, and we can have a number for humidity, and if we the threshold of within high and low is between like 50, and from 49 to 51, between this the humidity low and high changes. So through slight changes, the whole decision can change for a particular decision tree. So that's one of the disadvantages. And what happens also if the tree is particularly deep? What do you mean by tree is particularly deep? It means it has more number of nodes. So what happens is at each stage, as you go below, the total samples, the size available in that particular node decreases. And that's where like you have lesser observation for the particular criteria. And in those cases what typically happens is your model overfits it. So it, when you say overfitting, is that it models the noise rather than the actual pattern. And what happens if it's an overfitting? I think we all know is that if it's an overfitting, then it tries to really predict very well the training data. But whenever it sees some other data which is not in the similar to a training data, it gives a very, very bad prediction. So the validation accuracy is really bad for that. So to handle these cases, we need to think of something which is beyond decision trees. Now, let me give you an example. And this is the IPL season, and today we have matches between Gujarat Titans and Delhi Capitals. I want to give you some examples. So, say you need to predict the question instead of what Vinit said, like predict whether a tennis match will be held today. I am putting a question whether Delhi Capitals will win today. So for them, these are the typical questions which you ask, and these are part based on yes and no. The trees will be made, right? So some of the questions would be: is Delhi Capitals playing at home today, home or away? That could be one of the question. Then if it is so today they are having an away game, so you go to one phase, and then it says does Delhi Capital has a higher win percentage. So based on that, we traverse the tree, and then we can have any number of questions available. For example, is the leading scorer playing for Delhi? Is the second leading scorer playing? Is the leading wicket taker playing? Is it a spin condition or pace condition? There can be any number of questions, and all of this could be relevant. But the key problem is, as we have the more number of questions and all, the total sample we have for training is limited, right? For this part, so there is a huge chance of overfitting, and that's why it won't be able to generalize a particular model in training it. So for that, typically what we use is something what we prune the trees. Rather than having all this, we we know that there will be higher bias, so we won't be able to give like there will be error in bias, but still we prune the trees, or else we won't get enough samples to work with, enough training samples to work with. So this is typically what happens. And to handle this, we have found like if we are only having this pruning of trees and only three questions to answer a particular problem, we know that there is a bias which has crept in, and our model will have lesser variance obviously, but then bias will be high. So the question comes is, we know that a single decision tree does not perform well. So the question was, what if we learn from multiple decision trees? Like we know that decision trees are fast, they can be run parallel, so there is a chance that we can have multiple decision trees, right? So what if we can learn from multiple decision trees? Now, obviously, the key point is here is to make sure that even if we have multiple decision trees, they do not all just learn the same thing, because if it is the same thing, you are not learning extra from that. So think of it like a common wisdom circle where everybody is sharing something, and you are gaining better by getting the information from yourself as well as shared by others. So that's where you are getting the ensemble method and the benefit out of that. Now, this is where we have a technique called bagging, which is bootstrap aggregating method. And don't worry if you don't understand what bootstrap is. We have a slide for it in the next. But it's a method through which we would want to have a low variance here. So in any prediction model, we can use a methodology called bagging, where we are using the ensemble techniques. So what's the premise? So say if we had multiple realizations of the data, or say multiple samples we have here, we could calculate the predictions of whatever the model, like predictions whether there is winning or not winning multiple times, right? So we are having multiple realization of the data, like multiple samples, and we are calculating the predictions multiple times. Now, what is this sample? That's what we will talk about. We'll talk about when we talk about bootstrap. But think of that, rather than taking the whole set, the whole training data, I'm just taking a sample of the training data. And if we could and creating a tree out of that, and if you could calculate the predictions multiple times, and take the average of the fact that multiple estimations produce less uncertain results. So that's the whole premise of bagging. Uh, with that, I want to explain the idea of bootstrap. So the idea is, say we have say n is that whole training size or the sample size. Rather than get the whole one, the whole chunk of n training sample there, we are randomly selecting the datasets with replacement. So whenever we do replacement, the same observation, the training observation can come twice or thrice in the sample. So that's why what we are saying is that we are generating different epochs or iterations here by making sure that every time we are selecting something, selecting one observation, and then randomly drawing data sets with replacement from the training data, and with each sample the same size as the original training data set. So instead of previously we had only one training data set, but with bootstrap we can have n number of training data sets created, where it is done with the sampling with replacement. So that's the benefit of bootstrap. You're just augmenting the data. And so what happens is that with that we have multiple trees, and we can average the result of the trees to say, okay, uh, this is my final results. So we can do that, right? And we have found statistically that bagging results in improved accuracy over prediction using a single tree. And also we found that since it is not very reliant on a particular training observation making, so it is less overfitting because we have multiple trees and ensemble results from that, so it will be less than overfitting. But there is a problem associated with the bagging as well. So what happens is that the prediction accuracy obviously is improved, but the interpretability is not there because in different cases you're using different samples, right? You're not using the same training sample all the time. So there is a difficulty in terms of interpretability, which we understand, but we take it because it improves the overall prediction accuracy. And the key part for which we are kind of saying this is that what happens is that in case you have a very strong predictor that a variable will be chosen all the time at the top of the tree. So what happens is that if you have a very important variable or very strong variable which shadows all the other variables. For example, say in this example, Delhi Capitals versus GT. Say Rishabh Pant is the key player or Warner is a key player. So if he's not playing, that means Delhi would have almost zero chances of winning or something like that. So if there are very strong some variables which are very strong, or what we call a strong predictor, then we know that as per the decision trees, it will be chosen at the top most of the time. So even if you have multiple trees, the question which we said, like we need to make sure that the trees learn different things. They don't learn the same thing. So that's the problem which will happen here is that they will always most often the top of the tree will be the similar kind of thing, and that's where most of the trees will look mostly similar. So in statistical terms, we will say that each of the tree, like if we have computer correlation between the trees, we will see that trees will have high correlation. So they are not independent, especially. So they will have very high correlation because of if there is one strong predictor variable, and which happens in most of the enterprise cases. So what's the remedy for it? So the remedy for it is if we can use something what we call as, so the key part is what we can randomly consider only a subset of the predictors. So rather than getting all say all the predictors we have, like say a p set of predicting variables. For example, in our cases we had initially 5, then we pruned to 3, right? So what, instead of this total 5 or total 10 ones, what we can randomly consider only a subset of predictors at each step, and that is what will remove the correlation between the trees. And that's where the random forest classifier, which is an extension to the bagging mechanism which we taught you, is useful. So that's where the random forest classifier, which is it uses the correlated trees. So if anybody could ask you a question, how is bagging different from random forest classifier, is because in bagging, what we are doing, we are uh, we are doing sampling without with replacement and taking different samples and making the average of it. Random forest is also similar. Along with that, in additionally, what we are doing is we remove the problem of correlation of the trees by only considering randomly sampling a subset of the predictors here. So the way to reduce variance in random forest is with not only training on different samples of the data, but using a random subset of features. So these are the two things you need to remember from the whole discussion. With that, I will give a pause and understand if there are any questions on the chat.
There are no questions so far, Sayan, but I thought, I don't know if people are clear about what is a predictor and, certain basic questions. So, so please don't be shying away from asking. They're asking what is bagging. So, and what is pruning? Pruning is like a regular pruning in a gardening. So, I mean, however, Sayan
Pruning
will
means
be.
cutting. Pruning
Yeah.
means cutting. So
So,
you're
yeah.
pruning the trees, you're cutting the trees. So as I said, why do you need to prune the trees is okay. Let me give it. Uh, so you can have n number of questions, right? These are all the predictors or questions. So how do you know, for example, how do you know whether a model is go- going to work is because they have different predictors. Like these are the variables in the model. With these are the questions which you might ask, and if and based on that, like a tree-like structure, you come to the end of the tree and decide whether the answer is yes or no. So whether Delhi is going to win, you are going to ask some of the questions, right? Now each of the questions will be important. For example, and that's what we said. Like there could be a strong predictor, like for example, is the leading scorer or is the star marquee player Rishabh Pant or David Warner, is he playing or not? If he's not playing, then chances of Delhi. Like for example, I'm from Bangalore, so I can give an example of Bangalore. So people who are following cricket right now would know that RCB is not a great state, and our only person, I think, at least before the last two games, the only person performing was Virat Kohli. So for RCB, it will be, is Virat Kohli playing, and it will come first, because if he's not playing, we know what the result is going to be, right? So these are the variables or the predictors, and by pruning, we are saying that we don't need so many questions, or we don't need to go so many. Sorry, let me show you the tree. So we don't need to go so many levels. So each of them are some questions, right? We don't need to ask so many questions, because as we go down, the number of samples which will have for which satisfy each of the right conditions will go less, right, as we go down. So the idea is for that's where in one of the hyperparameters we set a maximum number of trees, right? So at maximum level of trees, so we can't we should go down to beyond that level in some cases. So it's a good practice to prune the trees, which is what I said is you would be having lesser number of predictors, or lesser number of levels in that cases. And in that way you are obviously, you have a problem of increasing the bias, because through only these three questions you may not be able to correctly answer accurately answer all the time. But the key benefit you are getting is that from pruning the trees or reducing the number of levels is that you are also decreasing the variance. So if you are just having all the questions and you are trying to make it overfit to the training data, which you don't want to, that's why you do prune the trees or cut the trees.
And
Sorry,
what is
any,
bagging? What is bagging?
yeah. So bagging is an ensemble method. So what is ensemble? Ensemble is that through multiple iterations, through multiple trees or multiple objects, we learn. We do an average kind of a thing. So bagging is what comes from bootstrap aggregating. So B comes from bootstrap, and AGG and ING comes from aggregating. So what we are doing on a bootstrap, and I will show you in probably I have a visual which is which I should have bought it earlier. Let me show it. I think that will be make more sense. So you have n examples, right? N of the training examples and m of the features. And through n of the training examples, you have created this n training examples, right? And these are the variables and this. Now, for each one of them, now this one tree, right? For multiple trees, you will have multiple results, right? For each of the trees, you will have different results. So what bagging does is that it it gives like each of the trees will give you whether it's a yes or a no, whether the will win or no, right? And you average each of the trees, or in classification you take the majority of each of the trees and take the majority vote. So the whole process is called bagging, where you are bagging the like benefits, like you are having different kind of trees, each of the decision trees, each being trained on different sets of data, training data through bootstrapping. So we are making sure that it has the same number of training data. So if the number of examples is n, so we are making sure that there are n in total in the training data, but any one of the training data can be repeated. Any one of the training observations can be repeated. So based on that, the decision tree trained on that uh, here and here would be different, right? Because the training data would be different from here and here. And what we are doing is aggregating all the results of all this. So think of it, it's like we don't know about any one thing, but a mixture of experts, a panel of experts come, and these are each of the experts. They give a decision, and we take the majority of the decision. So that's what we call as bagging.
So, Sayan, I think the next question was, somebody's asking that, okay, why we calling it bootstrap aggregation when it can be also called, there's a majority voting instead of aggregation in case of classifier, like you just explained, right? We are taking majority of the number. So, why is it called bootstrapped?
Yeah, no, bootstrap is for separate. What I think the second question was what is aggregating is here I'm taking majority vote for classification. Now the same thing can be done for regression level problems where we need to give a numerical score, right? So for that case, what we'll do is we do an average of that. And what we have seen is that for each of this one, for example, let's say if each of the experts are given a task of predict the price of a 2 BHK flat in Bangalore, and each one will give one their opinions. What we'll do is I will average each one of them, and the one which comes in an average will be my answer, right? So, and I think what the other question was why it is called bootstrapping. So I have it here. So what Bootstrap does is that I have a training example. I with in examples I have a training data, right? So each of the training data, I'm making sure that I'm generating numerous samples out of the training data. So on the first case, I will select any one of the n examples and put it here. Then once the training data is put there, the observation is put there. I will again put the observation back in the list, and again in the second part, for the rest n minus one data, one by one, I will select any one of this total n. So each one of the training observation can come twice or thrice in the artificially created training data set, and that's what we call as bootstrap. So we are generating data with replacement, and the whole purpose of it is to make sure that the variance is less. Is it clear?
I hope so. So, let's proceed.
Yeah, yeah. So I have some other examples which can I think so I want to show you the random forest algorithm, which will make sense. So, so for these are the number of bootstrap samples which we are creating. So, let me see if I can draw something, or else it would be much more clearer. So, let me see if I can draw it here because I have it. Are you able to see my screen?
Yeah, you're drawing, right? I
Yeah,
mean,
if
this
I
is
can draw,
yeah, yeah, yeah.
uh, would you be able to see my screen? That's what I
Yes,
wanted to
yeah, yeah,
show.
yeah. We can see your screen.
Okay, let's say, mm, let's say, let me put a sample case. See, these four are our training samples, right? Now, this is our training sample. So so this is our training original sample. These four are there, and forget about these things. So in the bootstrap, what I will do if I need to do a bootstrap, so and okay, we're doing good with time, so probably we will have time for it. So how many what is so I can generate I can generate in total b bootstrap samples. So bootstrap number, this is number one sample which I need to create. So it will have the length of 4. So first one, say I can choose randomly out of this. Say I randomly choose this one. So let me put different colors. I think that will make sense. This is visible, right? What I'm drawing.
Yeah, yeah, it is.
Yeah. So let me delete this thing because this will unnecessary. Okay. So I have four spaces. In first case, I need to. So this I'm just generating one of the samples. I will generate total capital B number of samples or n number of samples I can generate. But I know that in one of the sample I will have only four observations possible. Now each of the observation I will select randomly. So say first line randomly I select the green one. So it comes first here, right? It's the first one. Second one again I will select any one of these four. Again it comes yellow. Then it comes the yellow one. Then I will put it here. So I'm copying it here and paste it here. The third time, again out of this four, I need to select one. Again, the green one comes. So, and say at the last part, say for the first time, the red one comes. So this is one of the sample which is created. Similarly, if you do bootstrap number two, this is there. I will go through the same thing. Say, let's select yellow one comes first here, the first case. Similarly, each of the samples are created. Like each of the samples will be created, and just a second. Let me finish it. And say in the second case, two times twice this one comes. So so each one will have the length similar to the training data length, and we can have n number of samples created. Now, out of so each one of these samples, we will train a decision tree on that. So decision tree one will give an answer based will give an answer of a yes or no, whether Delhi will win or GT will win based on this. Decision tree two will get an answer based on this parts. And what are each of these observations? These could be our matches, results of the matches which Delhi and GT and other players, other teams played. So this is how we kind of create bootstraps. And when I say something around this, like for B is each of the samples from 1 to capital V B, that is the total number of samples, bootstrap samples we have generated. So we are generating a sample Z of size n from the training data. And then we are growing a random forest tree to the bootstrap data, um, and making sure that we are generating uh, the predictions for each one of them, right? And then what we do is we output the ensemble of trees. So if it's like here in for this sample, and let's take example of this. Sorry, let's say three samples are taken. Three is very small. In general we'll have more, but let's say three samples are taken, and out of the three samples different outputs are there. In two cases, say GT wins, and so in the first case, say in this case, based on the tree, GT wins. In this case, which will be here, I think Delhi wins, uh, and here again, say GT wins. So if we can create something like that, then what we'll do is then capital B is 3 here, small b is 1 2 3, and we have created a bootstrap samples here, and based on that we have trained each one with a separate decision trees. Each one of the decision trees are separate. They are giving also separate answers. For example, this one and this one would have which although give the same answers but are separate decision trees, and we are aggregating or make since this is a classification problem, we are taking the majority of that. So we'll say GT will win. If it was this problem, which is more of a class regression level problem, say this is a house prediction problem, and it says the rent of a 2 BHK in Bangalore, and the first model says it's 50K. The second model say it's 30K or 40K, and then it will be an average of that. So that's what we mean here. So for to make a prediction at a new point, for regression we average, for classification we do a majority voting of that. Is this clear? Okay. Let me go to some other aspects. Is in each of the cases, in each of the cases, what we are doing is, we said like why random forest is different is that you are only using a subset of the predictors. So let's call this as M. Like the total predictors are P, and let's say the smaller subset is M. So here we say the default value of M, and this is what the inventors of this algorithm has given us some kind of a benchmark, which are good to follow and which generally has given better results. So for example, and these are some of the hyperparameters. So as a default value of M, we have seen as the square root of the total number of uh, predictors, and the minimum node size uh, for a like node to be there should be 1, and that's for a classification problem. And for regression problem it is p by 3, and the minimum node size is 5, because that means at least 5 observations will be there in a node. So this is what are the kind of tuning parameters. That's why we call it tuning, like which are a base guidelines you can think of. So say there are 100 observation, there are 100 predictors. Out of them, you will keep the aim as around 10, or that will give you better results. And if it is around 100 predictors, if it's a regression problem, keep it around 33. So but again, the key point is these are the hyperparameters which you can tune and you can check it. People do all kind of techniques like grid search and all other things to tune which one is better, and this will depend on the exact problem statement which you have. And this is what, as we data scientists, we play around. We look at the different combinations and check which one is giving better results. So the last point I would want to put it here is the random forest. This can be fit into one sequence. Like, for example, how do you validate the random forest? So we we have something called out of bag or OOB part. So think of something like if M is around P by 3, that means on average, two-thirds of the observation is not coming in the trees. Like, sorry, two-thirds of the features you are not able to see, right? Because we are limiting, as part of design, we are limiting the random forest to only look at p by 3 observations, or m number of observations. So sorry, p by 3 predictors. In that case, one way is to do some kind of a out of bag validation based on that, where you kind of you just the change the things and see if for the predictors which are not there, has the results been better or not. So as you do a validation error, where you train on a training data set and you have a validation data set and you get a validation error, similarly there in random forest we will have something called OOB error. That is, it hasn't seen this kind of data, and if this kind of error stabilizes, then we can deduce that okay, the training has been done and it can be terminated. So this is the basic of random forest. And as I said, like we are using M features, capital M features, sorry, capital P features will be there, because small p features will be there. Out of them, we are taking M, and there are n examples. So at each node, we are choosing only M features. So we're not choosing all the features or predictors. We are only choosing M features at each one of case. And then we have generated multiple trees out of it. Each tree will give you different results, because it's been trained on different training sample, as well as it is at each node cases it's getting div- it's getting the visibility of different kind of features. So it will, so the each of the trees will be diverse, and that is by design. And then we will take the majority vote out of it, and that's what will give you, for a classification case, the majority vote will give you the result in classification. And if it's a regression, we have to take an average of it. So this is a random forest in general. What I have is,
So, and I
I,
have a couple of questions,
sure, sure.
and they are like very, very long ones. So I don't know if I'll just lose them in translation.
Yeah.
However, the this question, which is very long, the core is how do we handle when we work with larger sets, as accuracy would be an issue in some cases. And this is because you said we take majority, right? So he's given an example that if you have 10 classifiers and it's based on subset of 2 or 8 classifier, if we take 2 as majority vote, the decision might be wrong in few cases. So the core is like, how do you, see the accuracy is right?
So if the so accuracy is, so it will give better than the normal individual tree accuracy. However, there are some, like obviously each of the processes will have its drawbacks, and random forest, what it does effectively is that it minimizes the variance. Like it, when I say minimizes, reduces the variance, so that but it generally gives you better accuracy than the individual trees. But however, as I would agree that if there is very very, like if the total number of strong predictors are very very skewed compared to the total number of predictors. For example, there are 100 features, out of them only one or two are strong features, right? So let me tell you something. So let me see if I can put it here. So there are 100 features in total, and aim is, as we have said, we can do a square root of this one, 10, that 100, that is 10. So at each go we are only looking at 10 features, right? Now out of these 10 features, say only two features in general are kind of like are really value-adding features or really strong features, then the accuracy would slightly impact there, because the random forest you're not getting much. So that is one of the problems it's there. But I think the key benefit which happens here is in terms of we are like, you can't overfit the data in random forest, and that's where the variance is less.
There's one more question. How individual training sets are defined and what is the basis, parametric or non-parametric? And additionally, what is the mathematical basis for selecting a particular training set for Bootstrap?
Yeah, so these are all random. So these are all random. For example, you will run a random number and say, you can do like between 1 to 100, you can put a random number. If it is 0 to 25, it's red. It's 25 to 50 is green. 50 to 75 is orange. And 75 to between 99 or 100, it's blue. So you just take it randomly, and that's the part of the bootstrap, and you create the bootstrap samples as per there. These are all randomly done. And sorry, what was the second part of the question?
Yeah, that was the question actually. That the mathematical basis. So you said it is random, right? So
Yeah, it's totally
yeah.
randomly, but bootstrap is done randomly. That's what is called a random forest, because we'd want to. So there is no way that we are favoring one without another, and we are not using without replacement. So this is with replacement. Like the same thing can appear twice or thrice or more. So
So
the weightage of,
if so, this is my question. I mean,
yeah,
with respect to you have said so. For example, the number is 10, and
yeah.
I have like like you said. For example, taking your case, three in all the three, I repeat 10. So the answer will have 10, right? I mean, it will be by. So like people said, wouldn't it be? Or maybe you're unknowingly selecting something because you're randomly doing. You don't know the sample
No,
size.
this is
So
training. This is training, and this is features. So I'm saying that here the total number of training size is four, because I obviously can't show more than four. That will take time. So this is four training size, and I'm each one of the observations have equal probability of being selected in the bootstrap sample. And the total number of samples, this b, that I can increase or decrease, obviously that I can increase as per as I want. What I will do is so these are the hyperparameters which we have. And sorry, you are saying that whether it's 10, and but the problem which I said was earlier was different. I'm saying this is not across training size, but it's about the features, the different features we have, and out of them, if the key features are very small, then the additional accuracy like which we are expecting would be lesser. Does it answer your question?
Yeah, I can see one more question. Can the majority vote or decision reason can be obtained as a summary to understand the decision taken?
As in that's the plan, right? The For example here, if I say this is DC or this is GT, then that's where I'm like I have b capital B is equal to 3 here, and I'm taking the majority of that, and then taking it as the majority as GT. Yeah, so that's how I'm taking the decision. So as a summary, as in you want to export it, so that based on sklearn library, I think we'll have it in Python. You will have a features to know and look at each of one of the trees, what samples they were trained on, what in fact what features they were trained on, and you would be able to look at that in sklearn. But generally you don't go that far because typically it's been an old algorithm, like from 2009 onwards. We have been hearing the name of it, and it's has been quite robust in kind of making sure that giving better results than logistic regression and simple decision trees in most of the cases. However, as I said, and this is for the next sessions to take, there are better techniques to even improve the accuracy. The next speaker will talk about something called boosting, which I will let the next speaker talk about it, which will have a better chance, and it's a different technology. What we are doing is more of bagging here, and the boosting has a better chance of improving the accuracy there. So there are better techniques as well, but this is quite a robust technique, and this is used because of the simplicity, because of the kind of minimum results which is giving us a better results, which is giving and low variance as well. So any more questions?
Is it possible to get a chart, bar, or pie to portray the decision or show to prove the decision?
Yeah, that I need to check in the sklearn, or there will be other libraries. So what I will do is, as I share with you, Anjana, I will share some links which will have some research into that. This is possible because it's like if you have the R. So R is a software in for statistical software, and it has some cases where you can go deep and get all the parts there. But the one which I will be showing here is mostly Python. So, and I'm using sklearn, which is more of a advanced tool, and that will just give you the basic results. But if you want, you can go through the documentations of sklearn through of random forest and of random forest classifier or random forest regressor in your case, and would be able to look at it. Um, any more questions?
No, no.
Okay. How much time do I have, Anjana? So based on that, I will
Yeah, so you have 30 minutes. 12:30 we finish it.
12:30.
Yeah.
Okay,
11
okay.
to
No,
12.
I thought I had to finish by 12. So
N-
no worries. Then I have some
No,
time.
no.
Yeah.
So you have some time, and in the end, maybe we'll open it up for
Yeah,
Q&A.
sure. Questions and all. Yeah. So this is one which I really wanted, which I wanted to share. I think it will take around 10 to 15 minutes at least. But what I will do is I will share with you. So this is one which I'm showing you based on like what people have done based on random forest. And since we're talking about cricket and all these things, so let me show you one paper which has random forest and all these things. So, and I will send this link in the chat as well. So this is a paper which talks about the baseball games, and what it says is basically what it predicts is something like what is the winning probability of the home team. So, and I think that's similar across any cricket league or any football league or something. So, what good about this paper and for people who are interested is they show you in cricket, like people who are new to sports analytics and all these things, they show you what are the different feature engineering you can create. For example, like it's not just a win percentage as I showed you in one of the slides, but what are the different ways where you can have the win percentage, what are the other factors, what is it like. For example, one of the features we could have taken is in the last three matches what is the win record, what percentage of wins they have in the last 3 months. So say GT has won all the games where DC has probably lost all the games, that would be something which is going against DC. So these are some of the features which you can look at while you were doing this. And there is some correlations which you can do some EDA and some correlations along with it to show the different ways in which like, and I will talk about this like win loss. There are different avenues through which you can deduce the features, and it's totally up to you. For cricket, there are limited, but this is. But what I like about this is that if compared across the logistic regression, which I believe one of my earlier speakers covered, and then does the random forest comparison, the kind of uh, and it's all about the it's talk about bagging or bootstrapping aspects, and tells us about the increase, like accuracy increase, not much here, but kind of accuracy increase from the normal models. And then it also talks about the feature score importance in each one of the cases versus decision trees, normal decision tree versus a random forest one. So I will put it in the slide. And what's relevant in our case is what we did in Telstra as part of the Deep Tech Club was, and I want to show it here is we ran a competition where we asked people to kind of create a model to predict the results of a game. And this was during the ICC World Cup, which happened in 2023. So what I'm showing is one of the cases where we can use random forest model. And I'm not saying it's the only model which can be used. Obviously, there's other bigger models like XGBoost and other models which can be used. But this is a good use case because random forest model is really what I like about it is the simplicity through which within 2 or 3 lines of code, basically it can be created through the sklearn library. And I wanted to give you a flavor of how to do, like since we have talked about the sports example, so probably this will give you a flavor of how to answer a problem on random forest, like how to create a random forest model from scratch on a example which you will be conversant with. So this is what we have. So I'm assuming most of the people would have some kind of idea about Python, right? So this is where we import libraries. We are using pandas, NumPy, and sklearn. So from sklearn is one of the key libraries which you use in all of the machine learning tasks. And you will, rather than importing the whole one, we are importing select part of trend, test, and split, and the random forest classifier for these cases. Trend, test, and split would be used for XGBoost and others as well, but random forest classifier is the typical one which we'll need for this case. Now, let me, and this is a collab example, so let me run along with you. Now, since what we did was, I have my, I've, I've put it on collab, so collab what it requires is it's free, so you guys can try it. And what you can do is you just need a Google account. So what I did was, this is the code where I wanted to drive it from my Google Drive. So what I want to do is I want to upload something into our Google Drive, and this is where there's a code for it. So what I'm uploading is I have two data. One is ODI data and one is the fixture data. So that I want to be uploaded. Now, what each of the data is, let me give you some idea. So fixture data would be more about, so this we did during the ICC 2023 World Cup, which Australia won. So during that time, this is the list of all the matches, and we had to. The problem was people to for the people to predict the results of each of the matches. Now this is the fixture, and then we have something called ODI data as well. ODI data is the base data which we have downloaded from ClickBuzz and other websites, and I think I it's also there in Kaggle and others, which gives you the matches from all. Like it will give you the match date, it will give you the ground date, it will give you the margins or by which it was won. It will be the wickets or runs. It will give you the team one and team two. Team one is the home team, and team two mostly is the away team. We know the convention, and it will give you the winner as well. So this is the training data, like based on which we have created the training data, and it starts from say 1970s. Yeah, it starts from 1970s onwards to I think 20, just some days before that 2023 World Cup. So we got this data. Now once we have this data, and let me go to my this model. So I have you see that I have uploaded these tools, and these are kind of saved here. Now what we need to do, and this is very easy. Like what I've done is I believe that what has happened beyond 4 years beyond, like doesn't make sense because it's not the same team which are playing. Players have changed. So made sure that I'm only taking data from 2018 onwards, and if I do that, this is how the data looks like. So it talks about, I'm not taking the date, but I'm just taking team one, team two, who is the winner, what's the margin, and what was the ground. Ground is because in some cases in India we have the spinning condition, so we wanted to take the ground, and margin is important where we will have the more confidence of which is winning. So uh, this is how the data looks like, and then these are just simple iterations where I have given the list of what are the World Cup teams, and then uh, like if you look at that, I this is where we wanted to create some kind of a dummy variable, or what in other cases we can do it by one hot encoding as well. So this says for each one of the cases, for example New Zealand uh, is a winner, that means New Zealand was there. So I've created the case where team one is Afghanistan, yes or no, that is false, true or false. So here only for New Zealand it's true, and similarly for team two there will be some other team for which it will be true. So this is how the data we have manipulated a bit, just for making it in a way that we can model it. And then comes the key part where we are doing the basic part where what we have done is we don't want the model to know what's the winner, right? Because we want to create the x and the y. So y is our predictor variable or predicted. We want to know who is the winner, and whether the home team or the away team is the winner, and x is the all other features which we have created out of here. Now that's why in the x we have dropped the y variable here, because this is a supervised classification problem. So now we have used from the sklearn library this one, which actually puts training data, testing data of both x and y, and creates it. So you can give the percentage, for example, what percentage of your whole sample will be test data versus that. You can change it at 0.20 or 0.15 based on how many one which you want to choose. And this is a random key state, which is the key or seed which you want to put. Why you need it? Because if you want to have the similar kind of settings replicated, you want to produce the same results, you need to put a seed here. And just remember it, you can put any other numbers here, but if you want to replicate the same thing, you want to put a seed here and put the same seed here to next time when you run it, it will split it in the same option. So then comes the key model, which I will be talking about. So as I said, it's a 2 or 3 lines code, and that's what I like about it. It's very, very easy. So we create an object of a random forest classifier, and it takes n estimators as 10. So what do you, just an open question to all, what do you think n estimators are? What are these? So this is the total number of trees, and max depth is the depth of node it can at least go to. So we are making sure that it doesn't go beyond 8, and the random state, obviously we can put a key there. So if you look at the random forest classifier in the sklearn, there will be a lot of parameters and hyperparameters, but you don't need to. And some, I would say better you put most of them into default and change mostly the number of estimators, max depth. If you want to have less more accuracy, you can increase it, or you want to, you can play around with this, the number of estimators and all these things. And then what you need to do is, you just, once you instantiate an object of random forest classifier, you just fit the model with the training one. So now you train the model. This is what lets you train the model. And then what happens is that you create a score, a score which the same thing scores on the trend. Then you need a score which, once you have created the model, it can score, it can inference on the test variable as well, the test set as well. So given the test set, it kind of scores something, and then you can see the training set accuracy, which is while you're training with the X train, Y train, what's the accuracy, which obviously will be higher. And then you check whether you also have the validation set or the test set, and you will check whether it's lower or higher. So let's run this. Hopefully it runs without an error. Yeah. So if you look at that, the training accuracy is 0.831. So that means what? That means like, okay, we can also give it more information to be trained, and it can do better. It has a 83% training. So assuming that whatever will test set accuracy will be lesser than that, and we saw the test set accuracy to 0.68, which for our case we found a good, reasonable enough, and we don't need to tweak around with the parameters or hyperparameters. So if we want to tweak around with some of the parameters, let's see this. Uh, I don't think it will make a difference, but if it is 3 or something, hopefully, if you look at that, the training set accuracy has gone down. So in order to have more, uh, like it, less bias, you can increase the number of nodes and max depth, and that will give you more accuracy here. So once you have it, then let me show how it is utilized. So this is the fixture data which we talked about, right? Let me run this. So the first match was on 5th of October between England and New Zealand, which we know what happened. New Zealand was a surprise team in that World Cup, and New Zealand won. But while we are doing it, and if you look at that, and I will tell you what the result is, what our model predicted, and it talks about most of the results. So what we have done is we have just made some changes like team A, team B, and all these things, and we have put winning team as none because for this case we have put it here. But the way to do it is, and then what we have done is, if you run this, we are able to see this, all about the dummy variables, and let's now predict it. So what I've done is, the prediction data set, the fixture data set, I have created similar to the training data set. Remember the trading data set, we had that one or two encoding type of thing. So we did that here. And post that, what we did was we predicted, and the formula is very simple. You have the random forest which model which is there, the class is there. You have something called predict proba, and you give the pred set which is this one, this training data set, well, this data set which you want to score. So you utilize predict proba, and you pass on that validation, you pass on the scoring data set there, and it will be stored in a variable called predictions. Now if you look at that, I wanted to make sure that there are some names and everything should be there. So if you run it here, so that gives you like the indexes within all. Why I need the indexes? Because I want to tell you what's the probability of which team winning. That's the key part. So if I run this, and this is just data munging, not much of data science over here, but more of a data munging. What I'm trying to do is I'm taking the probability which is calculating of one, and dividing it because the probability of both the, like, the score of both the cases, and setting it as the final probability. So if you look at that T1 prop, the part of this being part of T1 is this one, part of T2 is this one, but the same thing. What we have done is, because for each of the team right now, at least it can be a tie, right? Only one team can win. So what I did was, probability of England winning is this by this plus this, which comes to 0.89, and for New Zealand it comes to 0.11. Now, this is what the model gave us, and I think most of you will agree that before the World Cup, we felt like England was a much stronger team and was a key part to win the World Cup. But we all know what has transpired, right? So this, in general, is a way to create a prediction model, and I would urge people like you, if you're interested in cricket or any other games, to try it for the World Cup, which is there in June, or even in IPL matches. You can utilize the same. You can play around with the random forest, which gives you a prediction and all, but it's really simple. So with that, I'm opening to any questions you have.
Sayan, there are two questions
Yeah.
in the Q&A.
Mhm.
That's why do we correlate random forest in cricket match? Is it for canopy or sparkling sunlight? And dense forest can
Sorry,
give
is this
canopy
for?
shape. Sparkling or sunlight? Sorry, canopy slash sparkling sunlight. And dense forest can give canopy shape. I
Oh,
mean, sir,
sorry. I won't. I'm not getting it. Probably I need to. I don't know this. What's canopy and sunlight? Like, is it? Can you explain the one who has written this? Because I'm not conversant with the. If there is a like, why we have done with cricket matches is because this is an easy. See, the whole idea of creating an example out of cricket matches, because cricket kind of appeals to most of the people because it's the IPL season in among the audience, and I thought it would be an easier way to kind of show it, because what I wanted to do through it is that we can even have logistic regression through it, or any other even a complex model like XGBoost through it. But random forest is the easy one through which people can start creating their models. And uh, but the key part is testing the hyperparameters and learning how the whole process works.
there are two questions. One is of
Yeah,
whether a random forest can be applied to stock market.
yeah, it is.
And yeah,
It is,
so
but as one of the persons said, is that, and I will say right now you have better methodologies. For example, the random for see the stock market, you will require to ingest a lot of information, and I would say boosting techniques. Like if you're, because you're interested in the accuracy, right? You're interested in the accuracy mostly. So if it's you're interested in the accuracy, the stability of the model, and you want the best output, that's what the stock market is. It's all about winning big. then I would say you go for the boosting techniques like XG boost or some other better even. And if you have resources to run GPUs and all these things, uh, run a transformer based prediction. I think that will give you more things, because for stock market there are some other information you need to ingest, like sentiments from different news and all these things in real time. I think a transformer based models or something which is much better. But random forest can do it. It can predict anything.
So the second question is, can we use this random, so somebody's written random decision tree, so basically random forest,
Yeah,
to
yeah.
help doctors to leverage patient treatment and medical history within decision trees to effectively manage reaction or chronic diseases and validate their medication decision considering the data fluctuation on monthly basis or quarterly, whatever.
So if I get it right, whether it can be, it is used in healthcare, but I'm yet to understand like what you're saying, like the use cases. Can you?
Use cases, I think, is to understand the medication of the patients
Mhm,
and on the basis of fluctuation that is occurring weekly, quarterly, monthly, whatever you want to use as an interval.
mhm.
And how do they react to medication basically?
So how do they react to medication? So if this is a continuous, so the way I will answer it is that I see it more of a supervised learning versus reinforcement learning problem, where if you want to give it some kind of where you know whether one is working or not working, you have it readily available and you have the supervisor level data set, then you go for supervised learning methodologies like either regression or classification normal we have, like random forest, XGBoost or something else. But what I think you are trying to model is you would get interactions of reactions from what the patient is having. I would say if you're interested in that, you need to train your model in a different way, and for that we have something called reinforcement models, right? Reinforcement learning models, where you can give a reward if something is happening, and given negative reward if something is not happening or something. And that's what you need to learn a policy. It's a more of a learning of a policy rather than knowing beforehand whether it's a true or a false or something. So I think if it's the path through which you are trying to get numerous inputs and interactions, I will say like you might need to look at a different class of algorithms totally. That's called reinforcement learning, rather than supervised learning is somewhere where you're only interested in the end result. For example, in this case, I'm not interested let me give you an example here. For a cricket match, if I had that information in between where I'm saying, okay, if within a match I know that one over has gone for so many runs or so many wickets has been there, I'm giving these inputs and all these things. I think better to model it more of a reinforcement learning kind of case, where in supervised learning I only want to know whether it's a win or a loss for a home country or a particular team. So I think your uh, like the question from what I understood is that, and from the way where it would try to model the interactions in between, whether it is a walk, not walk, and give it as an input. It's more of a feedback giving to the back to the model and better suited for a reinforcement learning model.
So then there's one more question. How to choose the best N estimator? Does a higher value mean higher accuracy?
No, yeah, that's a very good question. Actually, there is a way. I was thinking not to touch the topic because it will open a can of worms. Because if you're interested, I will say look for something called grid search. Let me see if I find it here. Grid search. So there is something called grid search CV or something, but it's a method of performing hyperparameter optimization. I will say look at that. So for each of, like for example, you can look at this and choose the different parameters there. So I would say for your case, I can tell you, I have kept it at 10. You can keep it at 50. In general, for industrial use cases, the 50 gives a good number, because I think grid search is an overkill for doing that. Obviously, it will give you, why I say it's an overkill, because it optimizes through different sets of parameters and finds out which is the best one. That's what grid search, CV, and all these things does it, right? So, but I would, if it was XGBoost or some other algorithms, I would say obviously use grid search and all these things. What I like about random forest is that the results doesn't change drastically that much. Like even if it's the number of estimators is like beyond a point, beyond 50 and above, if you given 2000 or 3000, the results won't drastically change that much. So I would say stick within a level, and don't use complex things like grid search. But if you are really interested, you look at that. That's more applicable for hyperparameter tuning for other algorithms. Like, and that's one of the reason that I mentioned this, because if you look at the tuning part, this part like m is equal to like these are obviously these are hyperparameters, right? We can increase it, but these are just best practices which we say. We are not saying obviously the best values will depend on the problem, and you can use research and other things, but these are just best practices which we recommend. So for n estimators, I will say put at 10 to 50 and see what comes. If even if you try higher, I won't say it will give you better accuracy, drastically better accuracy or something.
Thank you so much, Sayan. So, we're also reaching
Yeah.
towards the end of this. Some people are asking for this Google Colab,
Yeah.
data. If
So,
you
so how
can,
do I share? How do I
so
share
can
that?
share the link of Google Colab. I mean, if it is shareable, if
Yeah.
it is,
Mm-hmm.
and I can, you can share it in chat also, and then perhaps as a top up to this webinar, I can
Mm-hmm.
share it as again with all the people who were a part of this webinar.
Okay. Great. Great.
Yeah.
Thanks, Anjana, and thank you, guys, for listening to me patiently, and thanks for all the questions. For the canopy ones, I couldn't understand answer it, but I will look at a question, and if I'm able to get some understanding of it, and I will try to get the answers to you.
Yeah, so there's one more question. Does frequency of training data set determine the accuracy?
No, no, and this frequency of training data set, as in what is frequency?
Yeah, so I don't know because it's like just this much question.
See, training data set obviously, okay, let me say you this. uh, Let me expect what frequency, by what it means by frequency. So it's the quality of training data set that actually obviously helps to bring better models, and that's not just random forest, that's any model, right? Now the good part of random forest is that through the ensembling techniques, and what's the best part of
So they've
ensembling techniques?
explained number of
Yeah,
oscillations per second.
of training data set.
Yeah, I don't know. I mean, what? So somebody had written number. Oh, so the both
No,
are different
frequency
people.
is number of oscillations per second. I know, but why? What does it has to do with training data set? Training data
Accurate.
set is n number
Hmm.
of training samples I have, a number of observations I have, or something. So, are you
Yeah.
talking about the training size, like the number of observations or something?
Number of times of training. Number of times of training.
Number of times of training. Okay, so you're saying the B. This no, that doesn't. But that doesn't toward although it's a hyperparameter, you can test it out. So let me share that part. So what you are saying is this one, right? So these are total number of times in which we are generating this. So this is fixed because we have training size n fixed for that part, and but this is as per we can choose it, and this changes. But even if you change too much, it won't change. That's part. So the key part is you can't keep it very low because that won't make sense, but keep it between 20 to I think I've seen people keep it at 100 as well, but 100 to 100, there are a lot of like it's like creating, making sure that you're capturing the diversity in the data set, because as you create more number of bees, you what you're trying to do is you're trying to gain the ultimate coverage of the whole data set, right? For example, there are chances that there is a low chance that one of the training sample is not reflecting in any one of the one to B's. There is a very low chance, but not a non-zero chance that one could be there. So that's why idea is to keep it at least to a significant level. But if you keep it very higher, very high, that doesn't mean it will increase the accuracy or anything. The
And
whole point,
I mean,
yeah,
after all of the session, I still have a question. What is
sure.
bagging? If you can explain one with a real-time example.
Um, Bagging is simple. So, okay. So what's bagging? Okay, let me put it. I think it's better to draw it here, right? So whatever we have seen is, for example, for first training, it is if1. This is the score. For example, this is forget it about. So bagging is just I am not taking the normal training example. I am creating a bootstrap of example here. The capital B is 3, right? In this case, our capital B is 3, and then say I will have then three samples here: F1, F2, and F3. Now F1 is like the result out of this four. So n is 4, that is the training data size is 4. B is 3 here in this cases, and so we will have 3 trees, and we will be averaging these 3 trees. So say it's an Bangalore, uh, it's a Bangalore like case of where we are predicting the price of a 2 BHK. So somebody like me who stays in south of Bangalore says it could be around 50K. Somebody who stays near Belandur and all these things will say 50K is very less. I pay around 70K. But somebody who's staying in outskirts of Bangalore or something will say F3 is say 30K or something, right? So different experts or different people, based on the different training sets which they have found out, they are giving different predictions. So what we are doing to a bagging is an average of all these things, and and then what we are saying is that if we do some kind of a bragging or averaging of this, the variance is low here, because the key part of bagging, as I put it here, is it, it helps in the prediction model, which helps in lower variance. That's the key part. So, and we have seen that compared to the individual decision trees, it is giving that averaging is giving a better accuracy. So that's the whole concept of bagging here. So it's a bootstrap aggregation, as we say. What is bootstrap? Bootstrap is from the normal training data set. We are creating different bootstrap samples and getting the results, f of this training set, f of this, and then getting the actual average results as my final result. Rather than only doing it for one tree, I am training it for multiple trees by artificially creating some bootstrap samples and then averaging it out. That's by. So there are two techniques which I would want. What I will do is, since we don't have time here, so I would say, like, when the next speaker talks about boosting as a technique, I would want him to. I will ask him to speak more about bagging and boosting and explain the differences between that. But bagging is, in simple terms, if you think, it's more of an averaging through creating of bootstrap samples. Does it make sense? Hello.
I yeah. So I hope so, Sayan. They're saying yes, they understood, I believe. So with respect to the collab link, are you going to be putting it in the chat?
Yeah, post the call. We're just going to put it in the chat. Okay, I'm just
Oh,
putting it. Just let
huh.
people just let me know if you are able to, and I will be sending the. Is there a way I can share the Excel files, or else you can generate the Excel files as well? So let me put it in the. I don't know, like where is the chat? Okay.
Else, you can share the Google Colab link with, yeah, you have put it. So he's put the Colab thing which can be
Just
accessed
let
by
me know if
you.
you need access or something because I haven't checked that because I made it
Okay.
open, but just
Huh. So Sayan has shared it in the chat. All of you can click on the link and go to Google Colab. Of course, you'll need to open the Google Colab. It will directly take you to Colab, and you should have signed in there or something. So thank you so much, Sayan, for
thank
taking
you.
out time and walking us through a very, very, I mean, I would say a random, concept, which was in random forest. So it was nice. I'm also looking forward to collaborate and having some quiz card post the Telstra series that we have done. So I'll reach out to you separately for that.
Thank you. And if you want, I will share my GitHub link, which where they will have this code along with there will be like this will be an Jupyter code, Jupyter notebook code along with the data. So they can even do it for the current IPL or if they want to try it for the upcoming T20 World Cup as well. They can do that.
Yeah, that would be great. I think you can put the GitHub lab. I don't know how many people have Jupyter Notebook, but they can work it out on Colab.
So
So
there are
that's
people who may not have Google ID, so that's why the IPYNB, like that Jupyter file is will be there along with the data sets. So they will be, so they can just directly run it, and if they want the Anaconda or something, they can just run it and test it.
sure, sure. Thank you so much. Thank you,
Thank you,
Sayan. Thank you, everybody, for coming in. Bye bye.
thank you, thank you. Bye.